Good morning students, chemistry with DNA के साथ I am NAUMAN AHMAD. Today we are going to discuss another topic of organic chemistry, and that is Clemmenson reduction. Yesterday we discussed the topic Wolff-Kishner reduction. Today we are going to discuss Wolff-Kishner reduction. So Wolff-Kishner reduction, we studied Wolff-Kishner reduction, but today we are going to study Clemmenson reduction. Clemmenson's reduction. At the end of the lecture, we will be discussing the difference between Wolff-Kishner and Clemmenson reduction. What will be the difference? The main difference between these two is simply nothing but only one thing. What is that? The catalyst and reactant is different. Suppose it is also used for aldehyde and ketone. Aldehyde and ketone. Wolff-Kishner reaction was also used for aldehyde and ketone. Both can be converted into simply alkane. And this, what will be the first difference between this and what will be the second difference between Wolff-Kishner and Clemmenson reduction? Here zinc plus amalgam, Hg, zinc amalgam will be used and HCl will be used, and the third one is it is acidic medium. And we can discuss later on many things, but these things are very important. In the previous lecture in which we were discussing Wolff-Kishner reduction, there we discussed that in place of zinc and Hg we took hydrazine, and in place of HCl we used there KOH, but now this is HCl. This HCl means this is acidic medium, and whenever we use KOH in Wolff-Kishner reduction, we used NH2. In place of HCl we used KOH, and an acidic medium, that was basic medium, and in the presence of ethylene glycol, it is it acts like a solvent. Now see what will happen. The simple reaction in this compound is zinc, these two will be replaced, and only H2 will be formed from aldehyde or ketone. It is simply reduced into simple alkane. So what is the mechanism? The mechanism is very easy. Let's discuss the mechanism. Mechanism is easy for these reactions. Mechanism involves some 3 to 4 steps. You have to remember it in a very interesting way. Like suppose in place of aldehyde or ketone, you can take anyone here. Hydrogen can also be present. CH3 and CH3 can also be present. Which means you can take it here. You can take aldehyde, and you can take also ketone. Both can be easily used. In the first step, what happens? As we discussed, zinc and HCl. Zinc and Hg, amalgam. What is the function of Z? Zinc loses 2 electrons. This is more electronegative, this is less electronegative. So here partial positive sign will be there and partial negative. So these 2 electrons will be attacked on carbon. So here one thing, O negative and negative will be like the same. Suppose what happened, we just removed this double bond because it attracted its bond, one we can say pair of electron towards itself, and here partial negative and partial positive is because these 2 electron is transferred to this one. So it is a change from -2. Now see here minus is there. What will happen? We used HCl. HCl will donate This is high molar electronegativity, it will attract its pair of electron, and hydrogen will be attracted by oxygen. So this is a kind of compound will be formed like the same. Now, so though two HCl will be used, why? Because one hydrogen will come here and the second will up. So OH will be formed and H will be formed. This is the second step. Now, very interesting thing is there in this reaction. Now you can say, okay, again water will, now see, again in HCl reaction, hydrogen will attracted because it has a lone pair, so hydrogen will be attracted. So this reaction is like the same H2 and H. Now see here, positive charge shows okay, it is just going to form water molecule. So water molecule will be removed, here water will be removed, this whole compound will be removed, and here minus charge, plus charge will come here. Now see here, plus charge means it wants 2 electron more. So these 2 electron will be provided again by zinc. Zinc loses 2 electron because it is present, and these 2 electron will be attracted on the carbon. So again what will be formed? CH minus, and this minus, now again at the end HCl will again come in the picture. HCl again will keep its pair of electron, and hydrogen will be left alone. So that hydrogen will be attracted by this aldehyde or ketone. Simple, you can say that aldehyde, yeah, suppose if it is acid aldehyde, so it is changed into ethane. If it is ketone, suppose CH3 and CH3, then it will be, then it changes into propanol. So this is the simplest way of Clemmenson reduction and Wolff-Christian reduction. So the difference between Wolff-Christian, okay, in Wolff-Christian reduction we used hydrazine, let me write its name, hydrazine. Basic medium is used in because KOH acts as a basic, and ethylene glycol is a solvent. Here there is no function of ethylene glycol, it acts like a solvent. So this is the best way to compare Wolff-Christian and Clemmenson reduction. It is very important in organic chemistry. If there is any question, you can ask in comment section. Till there, take a very good care of yourself. Assalamu alaikum.